Let everyone know that they're being recorded. Okay, so we can start. Okay, so now the first thing is we need to extract our My apologies, the laptop switches off. Okay, it means I'm tired. We are all tired. Even the technology is tired. Can you see the screen?
Yes, ma'am.
Yes, ma'am.
Okay, so the first thing we need to do is make sure we arrange everything properly so that we have the matrix A. Then we have how many x, x1, x2, x3, and then we have the matrix B. And because Lucky asked all the constants already in the right hand, on the right hand side, this is 2, 1, 3. And then after we have 3 minus 1, 1, 2, 1, 0, and then 1, 2, negative 1. Did we all get that?
Yes, ma'am.
Yes,
Now,
ma'am.
the first part, because they want us to solve this equation, the first part is we find the inverse of a metric. Step 2, we'll look for the inverse of a metric. And to find the inverse of a metric, we need to find the determinant of A, which is 3, 2, 1, negative 1, 1, 2, 1, 0, negative 1, and that one. So we'll use that one, the whole cofactor minor thing to find the determinant. So then so let's choose the first to work with the first row. So it will be 3, and we know 3 is in position 1 in 1 row, 1 column 1, so that will be 1 plus 1. And the cofactor for that, you remove this row and you remove this column. So we have 1, 0, 2, and negative 1. The next one is plus minus 1. But then now we have minus 1 because this negative is actually in the first row, 1 plus the second column. And then the minor for that is the first row and the second column, meaning that we're left with 2, 1, 0, negative 1. 1, negative 1. Okay, then we're done with that one. Then the last part we're going to work with is plus 1. And then we know that this plus 1 is in the first row, third column. So first row, negative 1, 1 plus 3, where this represents the first row, and then this represents the third column, right? Then the minor is first row's third column. So the minor is 2, 1, 1, 2. So 2, 1, 1, 2. Are we all together?
Yes, ma'am.
So then this is equals to 3. So, okay, we can solve that. We can just simplify. So this is 3 because this becomes positive. Then we have 1, 0, 2, negative 1. And then here we have a negative there, right? That negative times this negative gives us what? A positive. Do you see that? So that's plus 2, 0, 1, negative 1, plus, now this one to the power of negative to the power of 4 is just positive. So this will be 2, 1, 1, 2. Are we all together there? So then this will be equals to 3 times, because remember this minus are determinants. So this is this times that, right? Minus this time that. So that's negative 1 minus 0, which is just negative 1. Then plus this times that, which is 2 times negative 1, which is negative 2, plus 1 times 0, which is just 0, plus 2 times 2, which is 4, minus 1 times 1, which is 1. So then this becomes minus 3, minus 2, and plus 3. So then this becomes minus 3, minus 3, minus 2. Therefore, our determinant is equals to what? Therefore, our determinant for A is equals to negative 2. Are we all together there?
Yes, ma'am.
Now, we then go find our cofactor matrix, right? Our cofactor matrix, because we know that our A is equals to a 3 by 3 matrix, right? So meaning that C will also be a 3 by 3 matrix. So it's C11, C12, C13, C21, C22, C23, C31, C32, and C33. Are we all together there?
Yes, ma'am.
So meaning that we're going to do that C11 is equals to negative 1, 1 plus 1, M 1, 1. And what did we get there? We got negative 1. I'm just going to write answers because in the previous video, we showed how to find these C11s, isn't it?
Yes, ma'am.
Thank you. So C12 is equals to negative 1, 1 plus 2, M12, which is equals to what? In this case, they gave us is equals to 2. And then C13 is equals to negative 1, 1 plus 3, M13 is equals to 3. Then C21 is equals to negative 1, 2 plus 1, M21, which is equals to C21, they got 1 there. And then C22 is equals to negative 1, 2 plus 2, M22. In this case, C22, they got negative 4. And then C23 is equals to negative 1, 2 plus 3, M23 is equals to, they got negative 7. Then we have C31 is equals to negative 1. M, it's 3 plus 1, which is M31, which is equals to what? They got, in their case, they got negative 1. And then C32 is equals to negative 1, 3 plus 2, M32, which is equals to, they got 2. And then C33 is equals to negative 1, 3 plus 3, M33 is equals to, they got 5. And therefore, the core factor matrix of A, so the core factor matrix of A, which is C, is equals to, so this is their core factor matrix, negative 1, 2, 3, 1, negative 4, negative 7, negative 1, 2, and 5. Are we all together there?
Yes, ma'am.
Now, because we are looking for the adjoint, we know our determinant is what? Our determinant is negative 2. So we're looking for the adjoint now because we are looking for the inverse. So we then go and say adjoint of A is equals to the transpose of C, which is the transpose of the core factor matrix. So we know transpose rows becomes column, column become rows. So this is negative 1, 2, 3. And this is 1, negative 4, negative 7. This is negative 1, 2, and 5. Are we all together there? Good. Now that we found the adjoint, then we find the inverse. We know the inverse is equals to 1 over the determinant of A times the adjoint of A, which is the same as 1 over the determinant of A times C transpose. In this case, our determinant is negative 2, so it's 1 over negative 2, and then C transpose minus 1, 1 minus 1, 2, negative 4, 2, 3, negative 7, and 5. Are we all together, yes or no?
Yes, ma'am.
Together, ma'am.
So meaning that since we found that our inverse, A inverse, is equals to negative 1 over 2, negative 1, 2, 3, 1, negative 4, negative 7, negative 1, 2, and 5. Now, what you can do is, now because we're looking for the system AX bar is equals to B, so meaning that now we'll say X bar, in this case is X1, X2, X3, will be given by the inverse of A times B, right? Now, the inverse of A is what we got, so this is negative 1 over 2. Then we have negative 1, 2, 3, 1, negative 4, negative 7, negative 1, 2, and 5. And then what is our B? Our B is what we got on top there, which is 1, 2, 1, and 3. Now, if you multiply that, you can first multiply these two together, those two matrices together. Then this becomes negative 1 over 2. Because this is it's a 3 by 3 matrix, and this is a 3 by 1 matrix. Inner matrix agree. It means the answer will be a 3 by 1 matrix. So then you can multiply these matrices together and take out the half for now. Keep it for now. And then this becomes negative 4, right? And then 6, and then 14. And then you can multiply the half inside. So x bar is equals to x1, x2, x3. So you can multiply the half inside. We know half times negative 4, which is positive 2, times negative half times 6, which is negative 3, and negative half times 14 is 7. Therefore, we have solved the system. Because we want to show that we understood our work, therefore we say therefore. You can either say therefore like this, or you say dot, 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 x1 is equals to 2, x2 is equals to negative 3, and x3 is equals to negative 7. Oh, and that's how we do it. Are we sorted? I'm removing this video. I'm stopping it.
Yes, ma'am, we are sorted.
Okay, thank you.
Thank you.